So today we define the sequence. Our topic is sequence. The word sequence comes from the Latin verb sequor. Sequor means I follow. I follow. So sequence means something to follow. In mathematics, sequence is a function from a function f from n into r is called sequence. This function is into, not onto. Or how we can express this? Suppose this is the set n and this is the set r. So in n the elements are this type of, so on. Suppose this f carries this one to some real number a1 and 2 is carried to a2 and 3 is carried to a3. Similarly, 4 is carried to a4 and 5 is carried to a5 and so on. Then a1, a2, a3, a4, this is we call sequence, and we use the notation for the sequence is this. That means n varies from 1 to infinity. Also, we use the notation simply an. Now, this is the definition of sequence, and because the meaning to follow. Now, where this sequence is following. So, this sequence follows some point. Finally, we reach some point. That point we call the limit of the sequence. Like sum or limit. How I define limit? A real number a is called limit of the sequence an if for each epsilon positive there exists some n in the natural number such that absolute value of an minus a less than epsilon for all n greater than n. So, if such a exists, we say sequence is convergent. And in other words, if this a real number is finite, then we say the sequence is convergent. So, this first you need to remember this definition. I explain what the meaning of this. So, here, this means, what is the meaning of this? An minus a less than epsilon for all n greater than m. What is the meaning of this? First we understand this. This means by the definition of absolute value, I can write minus epsilon less than an minus a less than epsilon, and this I keep as it is. If I add a to the whole inequality, what I get? This becomes a minus epsilon less than an less than a plus epsilon. Now you see this form an interval, and n is a natural number for n greater than m. This means an, I can say an belong to interval a minus epsilon, a plus epsilon. Now this condition imposed, that means n takes value m or afterward. That means I remove this. Here is n greater than m. Now you see, if I remove this part, mean a m plus 1, a m plus 2, and so on belong to in the interval a minus epsilon, a plus epsilon. Now we don't need this because we already have removed the terms before n. Geometrically, this means what? This means if this is a, then if I subtract epsilon from a, because epsilon is a positive number, so this is a minus epsilon, and I add, then this is a plus epsilon. So this means in this interval, in this open interval, am, if the sequence is increasing, then from left to right or from right to left, we explain this thing by example. But now this means am will be somewhere here and am plus 1 will be here. So all these terms will fall in this. Now perhaps you remember the definition of neighborhood. That means these terms fall in the neighborhood of A. That means if these terms fall in the neighborhood of A, then we say A is the limit point of the sequence. So here another question arises, the difference between limit and limit point. But okay, first I explain by taking some examples so that the concept will become clear to you. So if I take example, an is equal to 1 by n, and a simply here, a is 0, and take epsilon is equal to 1 by 2. Then the neighborhood of 0, this is 0, epsilon is 1 by 2, so 0 minus 1 by 2, that means this is minus 1 by 2. 0 plus 1 by 2, that means this is somewhere here. Actually this is 0 plus epsilon and this is 0 minus epsilon. So this is the neighborhood of 0. Now see what happened. The terms of the sequence are, first term is 1, second term is 1 by 2, third term is 1 by 3, fourth is 1 by 4 and so on. Now we have selected or we have choose epsilon is 1 by 2. So you see how many terms fall in the neighborhood of 0. This is equal to 1 by 2 and this is obviously 1. So this is 1 and this point is 1 by 2. This is 1 by 3. This is 1 by 4. This is 1 by 5. This is 1 by 6. So what you see? This term is not this term is not in the neighborhood of 0. But what about 1 by 2? 1 by 2 also not in the neighborhood of 0 because this interval is open. So you can say n greater than m means now m already decided. This means this is n is greater than equal to 2. Greater than equal to 2. Not even 2. This is 3. That means only 2 terms are out, other terms are in. 1 by 2 and 1 is out, other terms are in. If I take epsilon is 1 by 5, then what happens? This is 0. Now this is minus 1 by 1 by 5 and this is 1 by 5. So how many terms? And this means 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7. This is the terms of the sequence. So you can say this term and the bigger term of this, that means these terms are not in the neighborhood of 0. That means we say 1 by 6, 1 by 7, 1 by 8, 1 by 9. These terms fall, all terms of the sequence fall except 5. So what you say that here m is decided, m is 6. So that n greater than m means n greater than equal to 6 fall in the neighborhood. So now I told you the limit and limit point. One more thing, if such A in R exists, that is, which satisfy A n minus A less than epsilon for all n greater than m, for all n greater than m, then one thing A is called limit of sequence an, and second, in other words I say A n converge to A, or I write this simply, this is this, an converging to A. Now I can say the AN is convergent sequence if such A exists. So the sequence AN is convergent, and now one more antonium come here, divergent. If a sequence is not convergent, we say sequence is divergent. Sometime one more thing, there are one more type of sequence, oscillating sequence. This is convergent. One more way we can understand, if A is some finite number, that means the sequence converges to some finite number, then we say convergent. And if this A become infinite, we say it is divergent. For example, for this, if I take the sequence this, then this sequence converging to infinity, so I say this sequence diverges to infinity. I don't use the word convergent. Now, oscillating sequence. One more thing, we say oscillating sequence, oscillating sequence. Oscillating sequence are those sequence which keep oscillating. That means, for example we take -1 raised to n. This sequence in expanded form I write -1, 1, -1, 1 and so on. So this sequence oscillate between 1 and -1. That means sometime it take value -1, sometime it take 1. So such sequence are also not convergent and we call them oscillating sequence. One more example. Sometime we simply find the limit of a sequence just by replacing n by infinity. Also, a, sometime we write limit n approach to infinity an. So this is also one way that we call a is limit of, then also we call a is limit of sequence A. So these are the definitions we need to understand the sequence. Some examples, like my question is find the limit of the sequence 1 by n. Simply we can find the limit n approach to infinity 1 by n is equal to 0. This is one example. Again, I take the example. So here we can so the sequence an converges to 0. Again, if I take sine n, then you see the second example, limit n approach to infinity sine this. Now you see what happened. If this n increase, where this whole function will go. See, graphically I tell you, this is graph of sine is something like this. Something like this. This value is pi, this is pi by 2. So, as n is increasing, this function is not stable. It keep going up and down, keep going up and down. So, when n approaches to infinity, the value of the function, limit of the function, lie between -1 and -1 and so limit of sine n lie between 1 and -1. So sine n is not convergent because the function is not stable, always move up and down. One more example you can see. Suppose this is n plus 1 by n. Then what happens? The third, limit n approach to infinity of n plus 1 by n, then what happens? This become infinity and this become 0. So this is finally infinity. So sequence is divergent. If I say another example, n plus 1 by n. So what happened with this example? For limit n approach to infinity, n plus 1 by n mean I can write this limit n approach to infinity, this is 1 plus 1 by n, and this term become 0. That means 1 plus 1 by infinity, this is 1 plus 0, this is 1. So limit of this sequence is 1. It is same like you do in the functions. So these are the examples.